Now see, 2 days ago we studied exceptions, and I before beginning of the class of classes and objects, I immediately told you there are two kind of exceptions. One, built-in exceptions, which are directly available inside your Python, and second one, the user-defined exceptions. So you can create your own exceptions. But I told you that before you can define your own exception, you should have an idea of classes and objects. Then only you will be able to create your own exceptions. So now the time has come to create our own exceptions because we know the concept of classes and objects now. Okay, so how can I create? Very, very simple example. What is our requirement? Suppose I type 5-0. What I'm getting? I'm getting zero division error. This is the inbuilt exception which is appearing here. Okay, this is inbuilt exception which is appearing here. But what I want instead of that, I want to mention my own exception name and my own exception message. Own exception message we have already done by using the raise, if you remember. Okay, but here also I want my name. Here also I want my name. Okay, something my exception, previous exception, what I want to do. Okay, I can do that. How I can do that? Very, 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 very simple. Very simple. See, so what I'm going to do, I'm going to create a class now. And suppose class name is Pravir exception. Okay. Now see, what we're going to do. Okay. Do you remember in the Python, there was a parent class, which has all the exception inside it. Anybody recall which is able to capture all the exceptions? We use that when we don't know the exception. Okay, this is zero division error or a value error or file not found error. We use an exception which was able to capture everything. If you forget, remember, I just type Python 3 built-in exceptions. Okay, built-in exceptions. And if we go down, there was a class known as exception class.
Exception.
Right? It is this, right? It is able to capture this. So what I'm going to do, I'm going to inherit from the same. I want to inherit its capabilities to capture the exceptions. I'm going to inherit the capability of this exception class. Why don't I inherit? It is able to capture all the exceptions. So why don't I inherit this property? So I know I can inherit because classes in Python support inheritance. So I can do that. So in the bracket here, I can type exception. Okay, because I'm inheriting from same exception. Okay, I'm inheriting from the same. And here I create an attribute. Suppose I say a def underscore underscore init underscore underscore. Okay, again self message. And I want a message from the user, what you want to display. So suppose MSG. And for now, I'm seeing an empty string. By the help of this, we will be able to write whatever message we want. Okay. And then we set colon, simple, self dot message equals to this message. As simple as that. So we create one attribute message. That's it. Where we will be taking this message from the user. Perfectly. It has been created without any issue. Now see how can we use that. Let me run this. Yeah, that. Now I want to use it. And how I will use it. That's the main thing. Okay. So suppose I'm creating a function which I think may raise an exception, but I don't want to raise that exception. Sorry, may raise an exception. Okay. Suppose I want to write a program which I think, okay, it may raise an exception. Okay. So I want to, in that program, include my own exception, Pravir exception, instead of built-in exception, which is available. So what I can write def, see, I'm creating my function name is suppose subtraction, which takes two argument a comma b. Normal, I'm creating it outside the class, right? Normal, the way we create the functions. I'm writing a function def a comma b. Okay. And I put a colon. And what I want that all the time my result should come always positive. And that is only possible if that b is less than a. Okay. In case suppose a becomes smaller than b, I want to raise an exception. Okay. So what I'm gonna do here, I'm gonna come here. I'm gonna say if b is greater than a colon raise Raise. Now, which exception you want to raise? I don't want to raise built-in exception. I want to raise my own exception, which is Pravir exception. So if an error came, so instead of zero division error example, okay, in this case, if b is greater than zero, instead of zero division error, I will get Pravir exception here, okay, Pravir exception, and okay, as it's a class, so we create an instance of this class, right? And remember, how do we, if we need some argument, that argument we supply here, if we can press shift and tab here, you can see it needs an argument from me. Agree, everyone?
Yes,
This is
sir.
right.
Yes, sir.
Right. So here I can put my message. Here I can put my message, whatever message I want. Means I want message, whatever message I want to display here, I can put here. So I'm putting, suppose, hey, B is greater than A, which I don't want. Okay. Else what I want, I simply want to return A minus B. If everything is perfect, please give me A minus B, no issue. Let me run this. Okay. Let me run this. A function has been created. Perfect. Now let me call this function to use. Sub pass suppose 5 comma 2. Okay, everything is fine. Your B is less than A. That means I should get A minus B. Perfect. Now let me do the reverse. Let me do 2 comma 5. Okay, so what should happen now? Now Pravir exception will be raised because now your B is greater than A. Let me run this cell. And please check, earlier you were guessing zero division error like this example, and zero division error and their corresponding message were coming. Now what is happening? Pravir exception is coming. See, Pravir exception is coming, and here whatever message we mention is coming here. Everyone, please check it and tell me, is it okay now for now?
Yes, sir.
Yes, sir.
Okay, and suppose you want to, okay, exception has been raised. Exception has been raised, you created a function. But what do you know? You also know that raising, if exception is coming, it's a good thing, your program will be halted. So you should have an alternative how to handle this. You know that by using try and except block, I can deal with this. I can deal with this. How? I'll come here. I will type try. Okay. This way, if coming, I know it is going to halt my program. I don't want this. It's in try block. I said, okay, try. And we know this is the function. Sub function may create an exception. We get an idea. We have created this function this way. Okay. So we know that this function may create an exception. So anything which may create an exception, where we write inside try block or except block. Anything which may create an exception, we write where?
Try block, sir.
Yes, try block. Okay. So I'm writing, suppose here try. What I want to try? I want to try A equals to sub, same function I'm calling, okay, which I've created. This function sub, and suppose I'm putting an argument, any argument. Let me put first of all correct 4 comma 3. I'll tell you the reason. Okay, A comma 3, and everything is perfect. Then I want to say print A. I want to print A, but what I want to include, if this expression or any of the expression raises an exception, come to the except block. And we know that this subtraction will raise which exception? Which exception it is going to raise? You know, this subtraction function will raise which exception? Come here and see. Which exception it will raise?
Pravir exception.
Pravir
Yes,
exception.
Pravir exception, right? So you will write same thing here, except Pravir exception as allies. Allies, you can include anything. Suppose E, okay, colon, and the way we did handled earlier. Suppose I want to print it right now. What is this exception? Is all up. Okay. Now everything is fine. Okay. And now if I run it, let me run this. Right now it is correct. So what do you expect? I will get a correct output. I will be seeing 1 only. Let me run this. Perfect. 1 only. Okay. But if I run it with the wrong result, in which it may raise an exception. Suppose I interchange their position 3 comma 4. So as we know, this function has been designed to raise exception whenever second number is negative. Okay, and this is advanced programming practice. When you will be dealing with very complex project, then you will be using such condition. You will be creating your own function. You will allow them to raise your own exceptions, but on the developing point of view, you are becoming a Python developer only then. For machine learning purpose, you won't require that, but you may use them. Always require, right? Now we know that here itself, this function is going to raise an exception for sure, because we have designed this function this way. We have designed this function this way to raise an exception, right? It will raise the exception in this case. So immediately at this point, it will raise an exception. It will go to this line. Okay, so A will not be printed. In fact, E will be printed. My information about my exception. Let me run this. And you can say, I get a message corresponding A. Hey, B is greater than. Is it fine, everyone?
Yes, sir.
Yes, sir.
Others, please, if any doubt, please tell me. Actually, these are bit advanced programming concept, but you have learned a lot, so I don't want to skip anything. You should at least know these things, because you never know in future you may require such things. Is it fine so far?
Yes, sir.
So now let's finish this OOPS concept by discussing the small thing. Okay? Somebody may ask you, example, have you ever studied object-oriented programming systems, right? So, and how do you know that that language is supporting OOPS or not? So there are a few characteristics that you should know. That's a very small glimpse I'll tell you. Okay, there are certain characteristics for any language to be considered at OOPS, which are normally 5 characteristics. One, it should have classes and objects. Okay. First property should have classes and objects. And as we just saw, Python does have both classes and objects. Second, it should support inheritance. Okay, so we saw here the Python supports inheritance. Third one, polymorphism. It should support polymorphism. What do you mean by polymorphism? Simple. It has taken from a Greek word, and which means poly, and plus one word is known as morphos. Morphos means forms. Okay, so if we break it down in English, it means many forms. Poly means many. Poly basically means many, and morphos means forms. Okay, for example, if you talk about, remember, one operator, a plus operator. Okay, so this plus operator takes many forms several times. Okay, for example, if I operate it on integers, okay, if I operate it on integers, so it give me a simple 5, does the addition. But when I operate same plus operator, right, but on the string, like this. Okay, but I operate same operator, but on the string, then it does different operation in concatenation operation. Okay, so same operator is having many form. Okay, same operator is having many forms. So we can say that sometimes it is also known as operator overloading. We also call it operator overloading, but we can say that it is showing many forms. So we can consider it as a part of polymorphism. Next, fourth property, encapsulation. Encapsulation. And basically encapsulation means binding things together. Encapsulation. Okay, it basically means binding together. What you are binding here, if you saw when we created classes, right? So we on those classes we include the variables which we call as data. Okay, which includes your data, as well as the method which operate on that data, and we bind them all together in one class. In the data corresponding and the method which operate on that data, we bind them together. Okay, so we can say what is encapsulation? A mechanism where the data which we are calling as variables, okay, and methods which operate on data are bind together. Okay, this is what your encapsulation, and we did that in class. We created class, within the same class we put some variables, and then we put some methods which operate on those variables. Okay, we put some variables, and then we put some method which operates on those variables. So what we are doing, actually we are binding their things together. That is nothing but your encapsulation. And last one, a very simple one, is your abstraction. Okay, last one is nothing but your abstraction. Abstraction in simple words is nothing but hiding unnecessary details. The simplest example, hiding unnecessary details. And there are lots of examples of the same. For example, a real-time example I'm taking. For example, you went to purchase a car. Okay, you went to purchase a car. So how do you recognize a car? Okay, how do you see? Okay, first of all, you do all the analysis. Okay, this is the car. This much mileage it will give me. This much is the budget for me. You do some analysis. Ask from your friends. Okay, you are having which car? I'm planning to have a car between this range. So they suggest you something. Okay, this will be a better car for you. Okay, for example, if somebody recommends, okay, you want to go a safety first, then you can go for either Tata cars, or you can go for Volkswagen car. Okay, but if your budget, no, I want to look after the fuels or something, you go for the Maruti cars and a different thing. If security is not a concern, but mileage and maintenance is your concern, that's a different issue altogether. But what happens when we purchase the car? So what the car manufacturer does, they hide bonnet. They use a bonnet which is used to hide engine. Okay, is ever happened you went to a car showroom and they ask them, please open the bonnet, show me its carburetor, where is this car filter? Have you ever done that? No, you never do that. Those things normally, who opens those? The mechanic, when it went for the service, or when it there is some correction is required in some, or some tuning is required for that purpose. So what they did is, okay, I am a purchaser of the car, so what I require, what only things those are important for me are visible to me, like my steering is visible to me, a lever by which help of which I change the gears, the levers by help of which I do accelerate, brake, and clutch. Okay, some odometer by the help of which I see how much speed at I'm running, my car is running on, the points to control your AC and something, but never it is not visible to me. Okay, where is my carburetor? Okay, where is the engine oil? Those things are hidden somewhere. So only those things are shown to you which are necessary for you. This is nothing but abstraction. Okay, hiding unnecessary details, because if I'll show you everything, you will get confused for sure. You will get confused for sure. 100% example, and this has been happening quite a time. Suppose we have been using a function again and again. Remember, this is a function we have been using again and again. So we are using it directly. Did we know what is the code running behind it? No, we don't know, and never we bothered, because it is readily available for us. But of course it is doing something. So under the hood there may be something which is running under the hood. There must be something which is running under the hood. Yesterday we created some classes and imported them. Remember, we created some classes here and we import them. I forgot the name. What was the name? We imported them using the, yeah, this one. If I run it again, example, okay, I run it again. If I run it again, see what is happening. I am just using this add function. I'm just using this add function. It is doing 3 plus 4, but how it is doing, I'm not bothered. Okay, if I'm a user, why will I bothered what it is doing under the hood, how it is doing, how it is able to perform such kind of operation? If I create a string here, example, okay, if I created a list here, anything you want to create, suppose I create a list here, any list, suppose X, and which is element 1, 2, 3, okay, a list 1, 2, 3. So this is an object of a string class. It has certain methods, like if I press here, okay, and if suppose I do something, anything, suppose reverse a method, okay, I'm just using it. I know what it is doing. It is simply reversing the string. Did I come to know how it is performing? So what is happening? It is all abstraction. Unnecessary things are hidden. How it is doing, it is not visible to me. It is making my life easier. That is the best advantage one class is offering to you. Okay, so they are packing your methods. Only you are ready to use your method. If you want to study how they are doing, you have to go to the documentation. Those who want to do the research, go and do the research documents or their documentation which are available in the Python website. But right now, I can't. There is no way if I created a list to know how it is reversing. It has been hidden from me. It is readily available for me to use, the way the print statement is available for me to use. This is what abstraction. Only those things are visible which are necessary for me. And how it is happened? Because this X belongs to a list, right? And it's belong to a list class in which this method is defined, which you are using. And you never know, in the future, you may create your own class as we did yesterday. Remember, we made a custom class where we created, where it is, a simple custom class we made yesterday, which was having concatenation as well as arithmetic, right? We created our own custom class. Yeah. And we were able to use the same way that it is available. But that is that this is available by default by the manufacturer of the Python itself, or the creator of the Python itself created it. That's why it is available directly to use. But there are several things which we used to import. And in future, nobody knows, you may create some your own library, which you people may use. You never know. For example, there is a website. Okay, if I come here, PYPI. Okay, there's a website PYPI. See, Python package index. Okay, here what happens every time some new libraries are launched, they are coming here. Every time they are coming here, and as per your requirement, you may need that library, and you may publish it. You may give to the Python. Okay, I've done something in the Python. You may use it. It will be helpful for everyone to use, or mankind may use it for every purpose. They keep coming. They keep coming. Several things are available here. See, there's some trending projects which are available. Extract feed from URL. Somebody has created something. See, this is a language detection for news powered by fast text. So somebody has done something and they've launched their libraries. These libraries you can import. And if I click on this, suppose I click on Fastlane, so it is mentioned also how you can install this library and how can you use that library. Okay, so in the future you may do that, but what they do, they normally hide their abstraction. They create their classes, hide the things there. Only those things are visible to you which are required for you. Otherwise, it will be very much troublesome for you if you try to go everything deeper inside. I hope it is fine, everyone. What is abstraction? Please tell me.
Yes, sir.
Okay,
Yes, sir.
there is one more thing I want to tell you. If you people are aware of Java, there is a method known as public variable and the private variables. I think you people are there. Then directly you can mention with the help of public and private variable. In Python, there is nothing like that. There is no word like private and public, but people smartly do that. Let me tell you how. Suppose I create a class, suppose sample class, okay, and I create a init method, underscore underscore init underscore underscore self. This is the terminology actually, but I'm telling you, this is nothing but the people used to adopt. Okay, the professionals used to adopt. So suppose I need a variable which I want for other people to access easily. So I give it a name, suppose self dot a, and this value is 10. I'm just giving an example. Now suppose I want one more variable which I don't want other to be visible easily, which I don't want for him to be available easily, right? So I type self. This is a convention what I'm telling, dot, and then press underscore. Okay, this is a convention that if you are putting underscore before any variable name, it is a private variable. Let me show you. Suppose his name is B, and if it's give its value to be 2. Okay, let me execute it. This has been done. Let me create an instance of this. Okay, so the instance is suppose x is equal to sample. Okay, now if I access this x, and normally how do we access attributes and method of a corresponding class? I put the instance name, that is x, press a dot and press tab. This is normal procedure, right? After dot, we press tab. Let me press tab. I'm pressing tab only, okay? And only a is coming because only one variable is there. Let me put one more so that things will be much more clear. Self dot c is equal to 10. Okay. Execute it again. Execute it again. And this time, if I press x dot, how many are visible? Can you see? Only
Yes.
A and C. Okay. B is not visible to you. So you have made that private, but he can access it. But those person who know it, they can access it, right? If I put after dot underscore, okay, it is available for me. Can you observe that? If I press enter, I will be able to access that. But normally, how do we access attribution method? I press dot and I press tab. So all the attributes which are visible will be appearing here. Okay, so this is normal a way to tell, okay, this is a underscore, that means it's a private variable, we should not change it. Okay, this is the normal terminology. Directly your public keyword or private keyword is not available in the Python. That is normally people used to use in your Java. It is not available, but you can create some sort of privatization by using this underscore. There are certain rules, right? Normally programmers follow never put a name with starts with double underscore. They have some special purpose of these functions. Okay, so this is the thing. I hope it is fine. I'm just giving a brief idea. If somebody asks you, do you know what is object-oriented programming and what properties it should satisfy? So you should know. A brief, you can tell what it should support classes and object. It should support inheritance. It should support polymorphism, right? It should support encapsulation. It should support abstraction. If you want to become a pro Python developer, means you want to make a career in Python only, then you can go ahead and explore them more as per your requirement. You can explore them more, and there are something known as abstract methods. You can use them, you can learn them, but as per your requirement only. Okay, if you need them, if you want to make if you want to make your career inside Python developer. Okay, so I'm moving ahead now. Okay. Done. So with this, I'm done with oops concept. Let me save it and let me close it. Let's start now arrays. So I'm opening a new Python file now. Now we'll start with arrays. Okay, and we can say now from today we will be studying things related to data science only. Okay, basic foundation, what is required for Python, we have done enough. At least 20 hours, around 20 years we have spent on the Python. Now next 20 years approximately we'll be spending on our data science, means machine learning. We will study first of all NumPy, then pandas, then the very important, more than machine learning, which is important, is data visualization. Okay, so we are going to spend at least 3 to 4 sessions on that, and then we will study different machine learning algorithms. And those, trust me, understanding of machine learning algorithm is important. Implementation is just one line of code. Only one line of code you can implement your machine learning algorithms. That's not a problem. Okay. Main thing, you should know how those algorithms work. So let me come to the arrays. So actually what happens, if we see in by default, if we see the Python have different data structures. Like we saw list, a tuple, okay, we have dictionaries, sets, everything is available. Okay, and very close to array is your list. If you observe that, if I create my list, very close to array is a list like this: 1, 2, a, p, anything you can else you want to put. Suppose you want inside put a list 1, 2, and 3. Okay, but what is normally an array? Array is a collection of same type of data. First of all, then array is a collection of same type of data. So if I want to convert this my list in sort of array operation, then what I can have, I can create my list which should have only one type of data. Example, numeric data 1, 2, 3, 4. Okay, they will give me some performance. Similarly, I can create one more list like y list 1, which is having only and only characters like a, or you can have names as well. I mean strings B and C. Okay, this is the thing. So you can use list as well. You can use your array as well. First, let me discuss about the list and why we are moving to the arrays. So a list can have it is a heterogeneous elements it can have, means different. It is having string, it is having list, it is having numbers, integers. It can have floating point numbers as well. But if we talk about arrays, the arrays have one type of data. Okay, only one. If it is example your numbers, then it will have numbers only. If you're talking about the characters, it will have characters only. Okay, and why we use arrays? The simple reason is that if you want to perform high speed operations, okay, you want speed is the prime thing for you. You want high application is such like that where speed is a prime factor. You want high performance applications. Okay, for that scenarios, arrays work very well because there are several reasons behind that. Second reason, they are good for memory purposes as well. Okay, if you save on the memory, they will occupy less space. There are several reasons behind that. This is written like that: array occupy less space. But if you tell me, if you ask me how they do, I can immediately tell you. Simple thing is that suppose logically you can think of being an engineer or you are a professional, you can think of if I'm trying to store this list, okay, it is having a data type of type integer, it is having a data type of type string, okay, and again it is a string. If I create it, it's again a string, and second one is list, and it may also have a a floating point number like 1.2. Okay, it may have a floating point number. And this is one thing. If it's, you understand logically, if I try to store this kind of data, okay, and if try to store this kind of data, if you are a professional, right? If you are a professional, then you can tell me which will occupy less space and why, with the reason.
Second one will occupy less space.
Yes, second one will occupy less space, and the biggest reason is what? Simple. If you ask me personally, then I will introduce a logic. Okay, see, these are different data types.
Yes, sir.
These are different data types. Okay, so of course, what is happening if I try to save somewhere? For example, I want to send it to you, something to you, and suppose what happens is that my file size is big. So what we try to do, we try to compress that file. Okay, we run some compression algorithm on that, and then I send my file to you, because by the help of compression I can save the memory, I can reduce the memory size. What happens if I try to apply that compression algorithm, this kind of data, like which is integer, it is a string, it is a floating point number. So actually there is a no algorithm which is available for every type of data type. It's not like this, right? Means algorithm which can compress for every sort of data. Normally algorithms are designed for different purposes. Like if you are a numeric data type, perfectly I can compress you. If you're a string data type, I can apply you. But what is happening? It is storing heterogeneous data. Okay, so it's very difficult to apply compression algorithm. But if you're having one kind of data, if you're storing one kind of data, then what is happening? You can easily apply compression algorithm of the corresponding type. And because of the same, you can save your precious memory. And you can now guess why arrays are very memory efficient. Are you getting my point, everyone? Please
Yes.
tell me,
Yes,
right?
sir.
Right? Simple logic is there, right? Simple. And third one is that performance wise, they're also very good. Performance wise, because simple logic is that again, they are using one kind of data. One kind of data is there. All the time they are being using one kind of data. So performance wise and your memory wise, memory optimization wise, your arrays are very good. Okay, but that memory, of course, it will happen internally. But if you want to observe the performance between list and arrays, so you are not going to see in 50. Suppose this list is having 50 elements, your NumPy arrays, your any array is having 50 elements, and you are going to see, okay, I will see some comparison difference. You won't be able to see that. But if you have a huge amount of data, like 10,000 elements it is having, 1 lakh elements it is having, then you will see the actual performance difference. Okay, so if you have a large number of elements or large sequence of data, in that scenario you will actually see that your arrays are superseding your list. Okay, in those scenarios this supersede your simple list. So let's now move, and how do we use arrays? So by default, like we were using list, we don't have to import something. But if you want to use arrays inside your Python, it has two variants. One known as array module, I will have to import. Second, the NumPy arrays. By default, inbuilt, it is not available there, because we know that most of the time list will do that, and list is in terms of is more powerful than NumPy array in terms of heterogeneity. It can store various variety of data. If you want to one variety of data, and if your data size is not very huge, you can still work with the list only, like 1 2 3 4 you can store, and you can perform the operations. But if you want a lot more applications, okay, lot more computation, lot more expressions to be evaluated, then you have to switch for the array. No options. So the two variants, either you can use an array module or you can use a NumPy array library, right? Let me show you first, which is normally people don't use nowadays. People go for NumPy array because NumPy array is much more powerful than your simple array. It has a large amount of functionality, and once you see that, you will never ever go back to the array again. Okay, so how do we use first one? So we'll got from array module, import a class known as array class, something like this. Okay, from array, import array. Just execute that. Directly is not available, right? Then suppose I have a list L, and it is an element 1, 2, 3. Okay, execute that. And suppose now I want to generate an array from this list. From this list, I want to generate an array. So what I will type, suppose array name is A, I will simple type array,
Array.
okay, array, simple, put parentheses, okay, go inside shift and tab. What it needs, not clearly it is mentioning one yeah, it is mentioning you have to put a type code first of all, okay, and what elements you want to put. So type code is that, remember, can store one kind of data only, one kind of data. So you have to specify a corresponding type code, what kind
In
of data you want to store. For example, I want to store integer also has a two variant. Suppose I want to store integer, so I will put small I, okay, that is for integer. Press comma. Either you can directly paste this list here or you can type L here. Okay, simple. Execute this and check A. A will be now an array. Okay, and if you want to see what kind of type code you want to know, just go to the Google, as simple as that, and type Python 3 type code. Okay, Python 3 type. Yeah. Okay, these are the different ones. If you can observe, sign character B option is there, unsigned character B option is there, and how many size in bytes they occupy. And data type is also mentioned. If you can say that, mostly it is numeric, int, float, and one option of the character as well. That is Unicode character. Okay, so they are able to store your numeric data and characters. So depending upon your requirement, we use sign integer. So we just mention I. So according to your requirement, you may use a type code. What type code you want to store and how many bytes they are taking, it has been mentioned over here. Okay, fine. Now I can also create it this way as well. Let me go here. Okay, and I can come here. I can create a new array. B equals to array in bracket. Suppose I can put again I. And without even first of all defining a list and creating, I created from list. I can create from tuple as well, like 1, 2, 3. Okay, execute that, and if I check my B is again an array. Okay, and once it is an array, you can easily access the same way you access the list. Exactly same way you can access the list. For example, if I come here and press suppose B, and how do we access? First element I want to access B0, I'll get 1, right? If I use B1, I will access second element, that is 2. If you want to access last element, what is the last element? Index is 2, that is 3. And negative indexing also works. If I pass -1, I'll be able to access, right? So same way you access the list, same way you can do that. But there are very limited functions available. For example, if I come here, I press B dot and press tab, append function is there. There are very, very limited functions if you observe here. Very limited, very, very limited options. But if I come to, and very much functions are very much similar to your list as well, but very limited functions. But if I go and take the help of NumPy arrays, you will see almost all the mathematical operations that you can think of: log, anti-log, log base, asine, hyperbolic, cube, factorial, but even a lot more, whatever you want, almost what you can think of for mathematical purpose, those functions are available in the numeric Python. Okay, so that's why people, instead of using this array, go for NumPy. It is much more powerful. Okay, so I'm moving that to how to use that. You have to import a library, import NumPy, that is numeric Python. Import NumPy and create an alias if you want to, because normally people create an alias, because that way, instead of typing NumPy again and again, I have to write in smaller words, and most common alias is NP. But I repeat, not mandatory. I can create PS as well. I can create AB as well. Whatever I want to mention, I can mention that. But most of the people for NumPy, they follow NP. For Pandas, they follow PD. So better we follow what the terminology usually is. But it is not mandatory. You can completely skip this. You can search, type, import NumPy, and wherever you are putting NP, in place of NP, you can put NumPy. It's just an alias, a shorter name. So I can run this. So successfully imported the library NumPy. Now we can use it. Now we can easily use it. Again, let me create a list and let me convert into the NumPy array. Suppose list is my list. Okay. Again, simple numbers 1, 2, 3. Okay. And the best part is there, we don't have to specify this type code here. We don't have to specify. Okay, automatically it will take. Okay, so my list has been taken, and how will we create an array using NumPy? I'll type A. Suppose I want to give the name to the array to the A. So N. Now what allies have been created? NP. So put NP here. Okay, that's what I want to tell you. If you have not used this as NP, you have to type it here every time. NumPy. Is it fine, everyone? So instead of NumPy, wherever NumPy is needed, I can type NP. This line means just this. I hope it is fine.
Yes, sir.
Okay, wherever you want to
Yes, sir.
type NumPy, instead of NumPy, just place NP. Okay, dot array means I'm creating a NumPy array. From where I'm creating from my list. Just type my list. No need of type code here. No need of type code here. I'm just passing it here. Okay, let me run that and let me check. It's giving me an array. Is it fine, everyone?
Yes, sir.
Yes, sir.
Okay, and very much same way you can access it as well. For same way, A bracket 0, I'll get first element. A bracket 1, I'll get second element. A bracket 3, I will be 2, I will be getting third element. So same way I can access that without any issue, right? Now let's move ahead. I can check a shape as well. For example, A dot shape. Okay, so you get one element. Okay, now see, understand this NumPy actually has, I want to show you one thing before that. Okay, let me continue. This is 3. It is actually your NumPy has two variants. One 1D data, one 2D data. Okay, 1D we normally call it as vector, and 2D we call it as matrix. 1D we will call it as a vector. Okay, single dimensional will be known as vector, and 2-dimensional will be known as matrix. Okay, so let me create a 2D data. How can we create a 2D data? With the help of this C. So we create again a list, my
Sir,
list.
can you scroll up, sir?
Yeah, sure, please.
A
Here you
little
want?
bit more, sir.
Yeah, sure. Fine.
Sir, how can we access the element I, sir?
No,
Use
I
that.
is not an I is a type code. I
Okay,
is
sir.
a type code. It is just telling
Which
you
means
what kind
here,
of data you are going to put in the array.
like integer or character.
Yes.
Okay. Yes.
Yes. It's a type code. Okay. It's a type code.
Yes, sir.
It-
Thank you, sir.
Fine. Perfect. If you try to put other, it will throw an error. Do you want to see? I can show you. Suppose I'm using it again. Let me create here itself before NumPy. Where is NumPy? Okay. Let me try to do this. Okay. Array model we have already imported. I'm giving x is equal to array. Okay. And within that, suppose I type I pass a list, but having element 1, comma, suppose 1.2. Okay. Comma. Let me put 3. Okay. Let me run this. Can you see what I get? I tell them I need integer, but what I'm passing? Floating point. So it is
Float
giving me
values.
error, float values, right? Similarly, if I try to put a string, it will throw an error, but that is not the case with NumPy. I'll tell you. That's how it is smart, how smart it is. But there is some priority, I'll tell you. Within few minutes, I'm gonna tell you. Okay.
Excuse
So I'm
me, sir.
creating some list. See, and it's a list of lists. Suppose 1, comma 2, comma 3 element. And
Excuse me, sir.
yes, ma'am, please.
Sir, I have a question here.
Mhm.
Suppose if I want to, if I want to view the size of that particular thing, then in C and all we will be using size of operator, no, sir?
Ma'am,
Likewise,
here you can come back directly by shape. It
oh,
will tell you.
shape.
Yeah,
Okay,
shape is there, right? So it is telling me 3 elements are there. In
okay,
the earlier one, I'll come to that. Don't worry. Within 1 minute, you'll come to that. Okay. Now,
okay.
second element, I'm typing 5, 6, 7. Okay. And either here I'm coming 8, 9, 10. Okay. This is a simple list of lists. Let me run this. Okay. And now I will try to convert it into an array. Now see what is going to happen. I'm typing 2D because this is going to become a 2D data right now. 2D is equal to np.array and pass this my list to this. Okay, let me execute this. If you want to see it, first of all, check it. It's a 2D array. And how you want to verify? Just type 2D dot shape. Can you observe now? It is telling me it has 3 rows and 3 columns. Okay, 3 rows and 3 columns. And how you recognize from here? See, it has 2 parentheses here and 2 parentheses here. And earlier when we created this data, okay, this data, it is only one element. And if we check its shape, remember, it is showing only one dimension. It is showing only one dimension. It has only one dimension available. That means it is a 1D data. And how many dimension it is available right now? 2 dimension. That means it is a 2D data, and we will call it as a matrix. Okay, one dimensional data that has been created, we will call it as a vector, and it will be called as a matrix. But if we consider it one by one, suppose I consider only one row, first row, we will call it again as a vector. Again, it's a vector. Again, it's a vector. But if we consider as a whole, they are as a matrix, 2D. Is it fine, everyone? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Can I move ahead?
Yes, sir.
Yes, sir.
Okay. Any doubts so far? One more thing I wanted to tell you. Suppose what I'm going to do now, I'm going to create a NumPy array. NP. Actually, this is a written test I gave somewhere and they gave me such question. Okay. That's what I want to tell you. NP.array. And within that, I pass something like 1, comma A, comma B. Sorry, or 2. Can anybody guess what it is going to result?
It
You
is
get it.
going to result in an array 1 and ASCII value of A. and
No,
then
no,
2.
no, no. Actually, see what is going to do. What happens? NumPy has set some priority. Okay.
Okay.
So it is a integer. It is a string. It will check which has the higher priority. String has a higher priority, or
Okay.
integer has a higher priority. And whichever has the higher priority, it will convert entire data into that.
Okay.
Okay. It will convert entire data into that. So if I run this, you will see that if I run this, okay, and check X, can you see? It is showing
Everything is,
data type to be U11 and everything has become a string now.
yes.
Can you
Everything is
observe that? So depending upon the priority, it will set the data type. It will not throw an error. It will not throw an error. This is the basic difference between your conventional array and your
other
NumPy
array.
array, right?
Yes.
So it will set, you see, which has the higher priority, your integer, or same way we can check with the floating point as well.
Okay.
Okay. If I pass some number, like instead of this, if I pass 1.2 and 2, okay. So we have mixed data, integer data, and the floating point data. Let me execute this and check X. Can you see it has converted everything into floating
point.
point? Okay. So if you put a different type of data, it will, the definition of array is that can store one type of data only. So when it is creating an array, it will convert into one type only. Depending upon if you are putting multi-variety data, it will check which is the highest priority. According to higher priority, it set the data type.
So integers have lowest priority.
That depends. You have to see the documentation.
Okay,
Right
okay.
now, or whatever we have chosen means integer and string. Of course, integer is the lower priority, right? Here, integer in the floating point again, integer has the lower priority. So that
Okay.
the document, there are different codes are available. Different codes are available which you can observe. Different. For example, here if I put one more number like my name, okay. Let me put it. Let's see what happens. P. Let's put P. Let me execute this and see what code we are getting. Can you check? Here the code has been changed. Its data type is U11. Now the data type is
Is it
U32.
unsigned 32?
No,
What is that?
Unicode. They have used the Unicode
Unicode
word.
30.
U
Okay.
stands for Unicode. Okay. And what variant it is? That is 1132. There are a lot of numbers that it is impossible to remember. It's almost impossible to remember. You can check, okay, what it is. So, but you want to see, you can go to the documentation and check. But normally we don't bother. We never put data this way. We never put the data this way. We know we are going to create an array. So we have to put the data in one simple data type only. Is it fine? But I wanted to tell you, it will not throw an error. So when I gave a test, I don't give an error. Honestly, I will be honest. When I gave the test, I take on, okay, there are different data types. Arrays don't have this facility. They can store one kind of data and there are options available. It will throw an error. It will become an integer. It will become a floating point or something like that. I just thought, that's what I thought of sharing with you. Okay. So it should be clear, everyone. Is it fine? So it depends on which is having the higher priority.
Yes.
Okay. So now let's create the arrays different ways by using built-in methods. Okay. There are some built-in methods. Built-in methods. Okay. And if I want to show you, suppose I come here, I create this X, and any array if I want to create, I'll show you the methods different, but let me show you the power first of all, how powerful it is. np.array. And if you pass some numbers here like 1, 2, 3. Okay. If I press X and dot, press step and check the power, argmax, argmin, argpartition, base. Okay. Just see, conjugate. Okay. Very, whatever you can imagine, come down, max. Okay. Mean value, min value, come down, which you will be using. Reshape we are going to use. Okay. Abundance amount of mathematical functions that you require. Transpose, right? It is available. So various variants you want to find out about the data. So these are very much powerful, and these much functions were not visible. If you encountered the simple array, were these amount of functions are available? No, they were not available. Means you can do your statistics, max value, mean value, min value, right? And we just saw variance as well. If you want to find out about any data that is available, right? So there are lots and lots of options which are available over here, which you can explore as per your research requirement. Okay, this is my research requirement. I want to use this as per your requirement. So just wanted to show you it is how much powerful it is. Let's move ahead to the built-in method. There is one more way, several ways of creating your arrays. One way is you can pass a list here, you can pass a tuple here, you can create. Other ways are there. Suppose I want to create a tuple without help of your, so I want to create an NumPy array without help of using tuple or list. There is a function known as a range function. Like the range function was there, here we have a range function, and very much similar, very much simple. If I go inside and read this definition, see what it is saying. Start is optional. Okay. Stop is mandatory. Again, step is optional. Remember, very much like our range function. The same way, it does the same thing. Okay, exactly same thing. But just thing is that it is going to generate an array. Here they was generating a range object. Here it is going to generate an array for me. Okay, so suppose I specify 10 here. So what it is going to do, it is going to generate a NumPy array having numbers from 0 to 9.
0 to 9.
Okay, as simple as that. It is going to generate an array. That range function was generating a range object. Here it can generate an NumPy array ranging from 0 to 9. So if I execute this, you can observe it generated an array 0 to 9. Okay, same way I can specify, suppose I don't want to generate from 0 to 9, I can control that. It's in my hand, very much like your range method. Suppose I want to generate numbers between 11 and 20. Okay, 11 and 20. So what it is going to do, it is going to generate an array of the numbers between 11 and 20. Last one will be skipped. Before that, same way like this, a range function. So you can see I get numbers between 11 to 20 in an array form. Similarly, I want to get only odd numbers between 11 and 21, or 11 and 20, sorry. Okay, so I can just pass a step argument like 2.
2.
Yeah, same, very much same, almost same. So I'm getting an array. So this is simple way. There are different ways you can generate an array. One way we saw a range function. Another method, which will be requiring, especially if you are going to work in a research field, those people will be requiring. Sometimes what will happen, you may have a data like image data or an audio data, okay, where you want to perform some matrix operations, or you want to have some zeros available with you, okay, or some data which is having some ones only. For that purpose, suppose I want to create an array of only 0 elements, only and only zeros it is having. Okay, so I can type np dot zeros, np dot zeros, and it will create an array for me. Whenever I will add np dot zeros or something, it is going to create array for me. Suppose I pass 3 here, which is going to create a one-dimensional array of having 3 elements. All are 0. Okay, all will be 0. All will be 0. Simple. If you want to make a, no, I want a 2D data. So again, you can do one thing. You can come here, and here instead of 3, I can pass a tuple here, like 3, or you want to first of all read the definition. You want to read the definition. You can read a definition here. It needs a shape. Okay, it needs a shape. So shape, something is given in the form of this. You can mention this. A tuple form is given. So I'm giving in the tuple form 3, 3. Inside bracket, it will give me a 2D array having all the elements to be 0. Okay, it may be required for the research purpose. That's what I'm saying again and again, right? Again, similar to this, suppose you want an array having all elements to be 1. Like zeros, we have ones, numpy dot ones. Okay, same way. I need 1D data for 3 elements. Okay, I got them. I need 2D data, np dot one, same way, exactly same way. Nothing special to be done. 3, 3. You want to make 5, 5. It's entirely your choice. Just run. I'll get all ones. Okay, very, very simple thing. Similarly, what I can do, you must have heard about the mathematics. There is an identity matrix. Okay, so if you are working in a mathematics department or somewhere, or even in physics, sometimes you may be required to find the inverse of a matrix, or somewhere where identity matrix is required. Okay, so you can create that identity matrix by using I function. Okay, I post only one argument is needed. Means what, for example, I want to create identity matrix of 4 cross 4, then pass 4 here. You want to create a identity matrix of 3 cross 3, then pass 3 here. Let me create it, and you will get an identity matrix whose all diagonal elements will be 1 and rest of the elements will be 0. Is it fine, everyone?
Yes, sir.
Okay. Other ways. Let's move ahead. There is one more function known as linspace function. Okay, linspace. See what it does. I'm typing np dot linspace. Okay, what actually it does, I have to supply a range here. Okay, let me read this definition. Start, stop, and numbers. Okay, you have to supply start, stop, and number. It has by default taking as 50. So let me just supply start and stop. For example, I supply 1, 50. Okay, yeah, 40. So what it is going to do, it is going to give me evenly spaced numbers over this 1 and 50. Between 1 and 50, it is going to give me evenly spaced data. Okay, and we have seen that one argument it is taking by default. Let me press enter, and it should give me 50 elements. We want to check its shape, so let me pass here itself. Okay, let me copy it. How much elements it is having? By default, it was mentioned as 50. If you go inside the definition, I told you here itself, it is showing that number it's 50 by default. Okay, so let me check, verify that dot shape. Because it's an array, I can run that. Yes, it is giving me 50 elements. Suppose you don't need 50 elements, you want to control them, so it's in your hand. I can type, suppose I need just 10 elements, but when 1 and 50, which are linearly spaced. Okay, 10 elements between 1 and 50, which are evenly spaced numbers between 1 and 50. And how many numbers you want? 10 numbers you want instead of 50. Let me run this. And this time, if you can observe, we will have only 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these all are evenly spaced. You can verify them. These all are evenly spaced. And if I guess, I think the difference is 5.44 in everything. If you can observe. Okay.
Yes.
Okay, the difference is 5. So all are evenly spaced. So you can get as many numbers. Suppose you want to know, I want 20 evenly spaced numbers between 1 and 50. Then you can use that. Okay, that may be required in your research purpose. Okay, simple example. Now, similarly, I'm moving ahead. What happens is sometimes you may require a data from uniform distribution or standard distribution. Are you people aware about these words, please? Anyone heard these words? Uniform distribution or standard distribution?
Gaussian distribution.
Yeah, Gaussian is normal distribution, right? But
Hmm.
what about, yes, normal distribution? Let me type. That's you perfect. That is fine. But what about normal? Sorry, standard. Sorry, uniform distribution. Have you heard about it? If you don't heard about it, please tell me, Frank. No issue with that. Actually, these are statistics
No, sir.
words. These are statistics words. Okay. And in future, if you're planning to make your career in the machine learning, then study statistics properly. It will be required for sure. Okay. You should know hypothesis testing because they may ask you in the future. Hypothesis testing is required. Your several kind of testing, other testing is required, and your correlation coefficient terms. Several things are this which are required. Normally, if you see any machine learning course, a good one, for example, you great learning or you go for a triple IT Bangalore one. Every course is minimum 11 months because lots of things are required to learn. Statistics should be good. Even mathematics should be very, very good. Programming concept should be programming. We have completed not more than I can assure you, whatever we have studied, you won't require anything above that in programming whenever you're going to study machine learning anywhere. Doesn't matter. More than ample we have done. More than ample. Not required more than that. Okay. So let me tell you a brief example. What is uniform distribution? Okay. Let me open a pen here. Take a pen. Here. Okay. And what is happening? Suppose this is my y-axis and this is my x-axis. Okay. And suppose this is x something. And this is probability of occurring of x. Probability of occurring of x. Okay. And suppose I choose numbers. Suppose let's say 1, 2, 3, 4, 5, and 6. Okay. And what these numbers are representing? Suppose these numbers are representing the numbers of a dice. We play Ludo, remember? In Ludo, we have a dice. Everyone? Do you remember the dice?
Yes, sir.
Yes.
Yes, sir.
Okay, yes. So we have a dice. So these are all numbers. So if I throw my dice, can you tell me what is the probability of occurring of 1?
1/6.
1/6, sir.
What is the
1/6.
probability of occurring of 2?
1/6.
Yes.
Yeah.
No, 1/6. Again 1/6.
Every time
Yes.
same.
Yes, every time. It's a favorable outcome upon possible outcome, right? So all the time. So 2/6, not it is 2/6, it is only 1/6. What is the probability of occurring of 3?
1/6.
Same 1/6.
1/6. Okay. So every time you have equal probability. So the chances of occurring of number 1, 2, 3, 4, 5, 6 all have equal probability of how much?
1/6.
1/6. And this we can represent by your uniform distribution. I hope it is clear, everyone. When all the elements have equal probability of occurrence, when all the elements have equal probability of occurrence, this is nothing but your uniform distribution. I hope it is fine.
Yes, sir.
Right? So in interview, if you're going to give the machine learning, they may ask you, what do you have an idea about uniform distribution? Now you people at least can answer them. They may ask you, give an example. So simple example is there. If you consider a dice, every number has an equal probability of occurrence. If that is that, we can say that all these numbers come from which distribution? Uniform distribution.
Uniform distribution.
Fine. Similarly, there is second distribution known as normal distribution. Okay. Again, same thing I'm plotting. X and again probability of occurrence. Wherever we talk about the distribution, we'll talk about the probability. So again, probability of X. This is the probability of X. But in this case, your curve is not this simple. Your curve is a bell-shaped curve, something like this. Okay, where your probability is highest. Your probability is higher at the center of the curve. Your probability will be higher at the center of the curve. Example. Let me take an example. Okay. And as you move away from the center of the curve, your probability will decrease. Either you increase or you decrease. For example, in India, if we consider India, when the baby borns, okay, normally their weight is around 2.5 kg. Their weight is around 2.5 kg weight.
Yes.
Okay, most of the people normally when the Indian child born, it is around 2.5 kg. So most of the people born with what weight? Around 2.5 kg.
Yes.
Okay, so if somebody asks you, okay, a new child is about to born, what are the chances? Means what do you think? How much is weight will be? So what you will say? Approximately
Approximately 2.5.
2.5, right? Because it has the highest probability, right or wrong? This is the thing. It has the highest probability, So this is what your nothing but your normal distribution. Okay, very few people will be there whose weight will be above 2.5. I'm just giving an example. You can take it 2.6 or something. Okay, and very few people will be there whose weight will be less than. So normally we say that if a weight is above 2.6 or 2.7, the baby is healthy, or baby is good, very good, or something, or baby is beyond normal. And similarly, if baby is less than 2.5, doctor shows concern. Yeah, it's serious. The baby is having very less weight. We have to take care of them. So most of the people, the normal people, born with a weight around 2.5 kg. So probability of 2.5 kg weight is more. Similarly, if you give a set exam, that is exam normally the happens when you want to do graduation outside the India. Okay, so most of the people get their C grade, something like that. There is something. So there also they follow. There's very various cases where the normal distribution you will find. That's why the name is normal distribution, because normally you will find it everywhere. No, I'm not just taking an example. I'm not saying that's why it is called normal distribution, but you can remember this way. Normally, everywhere you will find the normal distribution, where something is like normal distribution. Okay. For example, we come to the North India. Okay. And if I ask you, what people like most to eat, a dosa or a chapati? So if I place different things here, right? If I place different things here, like chapati, suppose here I put a dosa, okay, here I put a chapati, here I put a pizza, something like that example. So what, and here I put something like different, for example, a fish or something. Okay, so if you'll ask me what people like to eat mostly in the night, so you will say most of the people will like what? Chapati. So your distribution will be like this, right? Most of the people will like chapati. But if you go to the south, this curve will again will be normal distribution, but it will center most of the people like dosa. So it will shift around this. And very less people will be like chapati. Hope it is fine, everyone. Getting my point?
Yes, sir.
Okay. So hope it is clear. So let me delete it and let me come here. So what we need, suppose we need some numbers from the uniform distribution. Okay, we need some numbers from the uniform distribution. So what we are going to do, we're going to write a function np dot random dot rand. Okay, np dot random dot rand. It is going to give me the numbers from uniform distribution over the range 0 and 1. In all the number that you will type will be between 0 and 1 only. So np dot random dot rand, and here how many numbers you want, just pass that number. Suppose I want 3 numbers. Okay, these numbers will be between 0 and 1 only, and they will be coming from where? From uniform distribution. Uniform distribution. They will be coming from uniform distribution. So if I run this, and certainly they will be between 0 and 1 only. Let me run this, and I get 3 numbers, and you can see these numbers have between 0 and 1 only. Okay, so if you need numbers between 0 and 1, and from uniform distribution, you have to use random.rand. Now, similarly, instead of uniform distribution, you need from standard normal distribution. There's a difference between normal and standard normal. The difference is that, let me show you with the help of a graph directly. That will be better. Okay. Standard normal. Okay. Your peak will be centered at 0. Okay. Your peak will be centered at 0. Normally, we kill that. The mean is 0 and standard deviation is 1. That is the normal distribution. But for your remember, your peak will be centered at 0 if you're talking about a standard normal distribution. If I come here and let me see any image, if it is available, it will be good to see. Can you observe this? The peak is centered around 0. Okay, this is your standard normal distribution. You can even check this one. Here also, if you see this image, the peak is centered around 0, and it is a standard deviation of 1. Okay, this is a simple thing which is available. So we want data from this standard normal distribution. Again, you can go back and you have to make a small change. You have to make a small change. Okay. This is how many numbers we got. We got 3 numbers. Suppose I want more numbers from the again a uniform distribution that you can also get. Example, you need 2D data, so you can do that. This is 1D data I show you. 2D data you want, just pass 3, 3 or 4, 4 or 5, 5, whatever you want. Okay. I get a 2D data. Okay. If you want to make it 4, 4, just make it 4, 4. Okay. Similarly, if I want from a standard normal distribution, a very small change I have to do. NP dot random dot rand, it's there. Just put n there. Just put n. Here it is rand. Here puts rand n. Nothing else difference. If I put 2 here, I'll get 2 numbers. These numbers are coming from your standard normal distribution, and here you may have a positive value as well as negative value. Doesn't matter, because in uniform distribution all the time you will be getting between 0 and 1. Here not is the case. You may get positive, you may get negative. As I showed you the graph as well. I showed you the graph as well. It was going in the positive direction as well. It was going in the negative direction as well. So you may get anything. Okay. So let's move ahead. And you want to generate again 2D data that you can do. Same way we did for earlier case. Suppose I want 2, 2 and put this, I'll get a 2D data. Hope it is fine so far, everyone.